Hi guys, welcome to day 2 of probability. We're going to be talking about independent and dependent events and multiplying probabilities. So have your notes out. I'll go through this step by step. Not a lot to this lesson, but follow along. Here we go. Okay, so this is probability and multiplying. Definitely suggest you guys take notes. This is being recorded, so you could always stop the video at any point. So what are independent and dependent events? So let's consider the following: flipping a coin and rolling a die. Okay, does the outcome of the coin affect the outcome of the die toss? Well, think about it. You flip the coin, it can land heads or tails. So now the coin is on, the table, and then you roll the die. Rolling the die, it's not like the die is going to look at the coin for affirmation and say, okay, because you landed on heads, I'm going to land on one, right? So they don't affect one another at all. So how about this one? From a stack of 30 flashcards, you do the following. You pick one, do not replace it, then pick another. Well, if you pick a card, let me go through this. Let's say that you want to know the probability of picking a 3 out of those flashcards. Let's say the flashcards are labeled 1, 2, 3, right, all the way to 30. And you want to know the probability of picking a 3. Well, the probability would be 3 out of 30. And then you go to pick another flashcard and you don't replace it. So now say we want to know the probability of picking, say, a 5. Well, a 5 would be not 5 out of 30, there's only going to be 29 flashcards left. So the picking of the 3 without replacing it did have an effect of the probability of the second draw. And if you were to want to know the probability of, say, a 29 on the third draw, I'm sorry, this would be, oops, let me go back. This wouldn't be 3, it would be 1. This would be 1 as well. 1 as well, because there's only 1 3. Sorry about that. So you'd have a 1 in 30 chance, and then you'd have a 1 in 29 chance, and then a 1 in 28 chance. So the idea is that because you didn't put the card back, you're changing the whole setup. Right? You're changing the setup. So those events are considered dependent events. So mutually exclusive is a different concept. This is if two events can't happen at the same time. For example, you can't win and lose a race at the same time, and you can't flip a coin and have it land heads up and tails up at the same time. Now, some people are going to get wise and say, oh, well, it can land on the side. Like, no, 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 no. We're talking heads up or tails up, right? And tails up at the same time. Can't happen. So when that can't happen, the probability is going to be 0. So what's the probability of winning and losing at the same time? Or what's the probability of flipping a coin heads up and tails up at the same time, right? Those probabilities would be 0. So finding the probability of independent events. Most of the time we look at the probabilities of independent events, okay? So as long as the events are independent, we can multiply their probabilities. And I'll show you a formula for this, but let me just do this one example. So at a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability that you grab a diet drink and fat-free chips? So here, the word and is important. Whenever you see and, think multiplication. The word or is different. We're going to get to that in another lesson. Whenever you see and, think multiplication. So let's see. The probability of getting a diet diet, and then fat-free chips. Okay, that's going to equal the probability of diet times the probability of fat-free chips. Well, the probability of getting a diet drink, let's see, there are 10 diet drinks and 5 regular drinks. So there are 15 drinks total. 10 plus 5 is 15 drinks total. The probability of getting a diet drink, of those 15 drinks, 10 of them are diet drinks. Now, we look at the chips. The total number of chips, there are 8 fat-free chips and 12 regular chips. So there are a total of 20 chips, which means the probability of getting a bag of fat-free chips is going to be 8 over the 20. And to find the probability of this, right, probability of diet or fat-free, it's going to equal these two being multiplied. When you multiply fractions, you multiply the tops. So this is going to be 80. And you multiply the bottoms. So 20 times 15 is 300. And 80 divided by 300 is 0.26 repeating, or about 27%. So this, or this are all valid answers. So let's think about what happened here. We saw the word and. We're dealing with a probability problem. They want to know diet and fat-free. Okay. Diet and fat-free. Okay. So we just find the probability of the diet and multiply it by the probability of the fat-free. Here we can actually do a test to see if two events are independent of one another. And I call this test for independence 1. So the probability of some event A, which could be like picking a drink, and B, which could be like picking chips, right? That is the probability of A, just like we did before, the drinks, times the probability of B, if and only if A and B are independent events. So this equation holds only if A and B are independent. So let's take a look at this situation and we'll come back to this equation. So if the probability of A is 0.5 or 50%, and the probability of B is 0.3 or 30%, and we know that the probability of A and B is 14% or 0.14, are A and B independent or dependent? We don't even need to know what A and B are. It could be spinning a spinner, it could be flipping a coin, it could be picking a shirt from your closet with your eyes closed. It could be anything like that. But all we know are the probabilities, and we're going to be able to tell whether or not these two things are independent. So they are independent if the probability of A and B equals the probability of A times the probability of B. Let's see, probability of A and B, just substitute, is 0.14. Probability of A is 0.5. Probability of B is 0.3. So 0.5 times 0.3 is 0.15. And notice 0.15 does not equal 0.14. Therefore, A and B are not independent, or they are dependent. So this would not be a scenario where it's flipping a coin and rolling a die, or picking chips and picking a soda. This would be more of a scenario where maybe you pick a card out of a deck and then don't put it back. These would be dependent events. Okay, moving on. A and B are independent events. Find P, A, and B. Well, because they tell us they're independent events, P, A, and B equals PA times PB. So P, A, and B equals probability of A, 1/6, times the probability of B, 2/5. That equals 2 times 1 is 2. 5 times 6 is 30. And this could be simplified to 1/15. Okay, 2. Tell whether the outcomes of each trial are dependent or independent events. Let's think. A month is selected at random, then a number from 1 to 30 is selected at random. So, okay, I mean, I can't really do it randomly, but let's say you throw a dart at a calendar and it hits, July. Okay, and then you go to a deck of cards and you pick from the deck of cards, you pick maybe a 7. Did the 7, was that affected by this? No, right? So these events would be independent. Okay, those events are independent. Let's look at 3. A letter of the alphabet is selected at random. One of the remaining letters is selected at random. So you have the alphabet, of course, is A, B, C, D, X, Y, Z, right? Now, let's say that you pull out, I don't know, C from there. Okay, so C is not in the alphabet anymore. The probability, first off, of getting C is 1 out of 26. And then one of the remaining letters is selected at random. So maybe we say, what's the probability of getting A? Well, it wouldn't be 1 out of 26. It would be 1 out of 25 because the C is no longer part of the set. So because picking the C, okay, affected the probability of the next experiment, we would say that they're dependent. I like to think about it like doing an actual experiment. Like, remember the experiment that we did when we were pouring the water with the dye and all that stuff, right? Every time you did it, you made sure that when you poured out one of the cups, you made sure it was totally empty before you poured in the next cup, right? But what if you poured it out and you didn't pour it out all the way? What if you left still a little bit of dyed water? And then you did the next experiment? Well, the next trial would have been affected by the previous trial because you didn't get all of that stuff out of the cup. And that's basically the idea with this is, does one trial affect the next trial? Here we've got the probability of A is 0.4, probability of B is 0.3, and A and B is 0.14. Are A and B independent or dependent? Well, if they are independent, okay, then the probability of A and B equals the probability of A times the probability of B. So let's just substitute some things in. Probability of A and B is 0.14. The probability of A is 0.4. The probability of B is 0.3. Well, this is 0.14, and this is 0.12. So 0.14 does not equal 0.12. This is a test for independence. This is a test for independence. Okay, this is key. It's a test for independence. It failed the test, which means they're not independent. So not independent. Another way of writing that is to simply say they are dependent. And I'm going to show you one last little thing here, just a notation. The probability of A and B is often written as probability of A, this symbol, and then B. So this symbol means and. Okay? Know that. All right, guys. So that's it for probability lesson. You guys will, after you watch this video, take a crack at the worksheet. Okay? Then Thursday, 1 to 2, we'll have a webinar. I'll go over this stuff, any of your questions. I'll try to go over some stuff on the worksheet, and then you guys will hand in the worksheet, and that's basically how the class will be run. We are very ahead of a lot of other classes, which means that we're going to finish our material way before the Regents. So if the Regents is still happening, I don't know if it is, but you guys will be 100% prepared. We do not have to rush. We're only doing 2 lessons a week, which means you guys should be experts. There's no reason that you should go through a week and look back and go, oh my gosh, I didn't understand math class this week because it was only 2 lessons. And you have opportunities to meet with myself or Miss M. That's 4 opportunities per week, or just email us. So you guys really got to start doing the work to make sure that you keep up on it. It's only, I think, 2 to 3 more lessons on probability. It's a short unit, although it's a really long topic, but I trimmed it so that it would be just important enough for what you guys need to learn in Algebra 2. Email myself or Miss M if you have any questions, and be safe.